To start this, let me explain why I'm having you learn SQL. I once interviewed an agribusiness graduate who they learned a lot of Excel and some Power BI in college, but they went to work for a grocery store and put in charge of dealing with data sets just way too large for Excel and Power BI to handle. So she had to learn to code on her own, including SQL coding. And she was not a computer whiz. She was not prepared. She had never coded before. And you may have to do the same one time. So I'm going to give you some exposure to SQL to show you that you can learn it also. It's doable. To begin, we want to open up Microsoft Access. And when we open it up, we want to start a blank database. We're going to be bringing data into this database. We want to save this database and make sure you save it somewhere that you can go and find later. Save it in a folder that you know you can access. I'm going to save this in a particular folder I saved just for this, and I'm going to name it sales data. Yeah, just sales data. And there we have our database. Now I want to go and I want to get external data. So I'm going to go get new data source from a file, and I'm going to find where this file is, and I'm going to open it. Now this is a file that I have to provide for you, so I'll have links to it on Canvas, and there may be assignments where each of you have a unique data set specific to you, where your data is different than any other person's in the class. And we open the data, and you notice this is a delimited data set, which means all the data is separated by commas. We going to tell it that the first row contains field names. Field names are like variable names or column names. And notice that in a data set, each field or column can have a different format for the type of information in there, whether it be text or whether it be a number or integer, something like that. Now every data set is going to have a primary key, meaning a unique number specific to each row in the table, and here I'm telling Access that my primary key is the field called the index. And now we import it to a table called sales data all. Now you're used to working with spreadsheets, not databases, so let me take a moment to explain why databases are different. So you can imagine a collection of tables in a spreadsheet. That's kind of what a database is. It's a collection of tables containing data, but those tables are linked somehow. For instance, here we have data on the price and quantity sold each day in the Stillwater store for each SKU. And an SKU is like the barcode number of a product. It's a unique number or code identifying the product. And there may be another table that has the same data but for the Enid store. So those two tables are related in that they're referring to sales data for each SKU, but they're in different tables because one has to do with the Stillwater store and the other one has to do with, say, an Enid store. Now the column numbers, the column names, we call those fields in databases. That's kind of like a variable name. And these fields are designed to allow only certain types of data. So date uses a time field data, store uses text data, quantity sales uses integers, price data uses numbers with 2 decimal places. And these databases, they're designed such that most of the time people using them have limited ability to alter the data. So like if you send someone one of your spreadsheets, unless you protect it, they can easily change it. Databases are meant to be protected to preserve the quality of the data. And as you see in the last column, there's a field called the index. Each table in a database must have a primary key containing a unique number for each row. Okay, we're gonna just finish importing it, and now that we've imported it, we can click the table name sales data all, and we can see the data here. It has the SKU, quantity sold, things like that. And I'm going to save this. And notice anytime it goes away, I can just click the tab sales data all, and it's going to bring up that table. There's a lot of different ways you can interact with the data in Microsoft Access, there's a thing called Design View where it tells you the data type, things like that. But we're mostly going to be with data sets that are already made that I'm giving you, and we're going to be interacting with the data set through something we call SQL, Structured Query Language. And let me show you what I mean by SQL. So most all websites are connected to some type of database. And when that website interacts with the database, it's going to do so using SQL language, structured query language. Here's an excerpt from one of my web pages, and you can see I've got this variable person where I'm selecting the name and the ID from a table called AGEC on 3213 fall 24 all, and it's from a database that's called Power BI data. Usually when you're interacting with the database, you're asking it to retrieve you some data. Here I'm asking it to give me all the data in the field names, name and ID too. And so you're asking it a question, you're asking the database a question, so we call that a query. We're going to learn how to write the query using SQL code. Let's say we want to create a query, so we're going to go to Create. We're going to go to Query Design, and then we're going to go to the left to SQL and choose SQL View. Now let's remember what our table of sales data looks like. Suppose I just want to select all the data that's in here. All the data that's in sales, the data all. Well, I can just go back to my Create Query Design, SQL. I'm going to go upper left, SQL View, and then the code there is select star. Star just means all. Select all the data from my table sales data all. And now I'm going to hit run, and it's just going to bring me all the data that was in that table. Now suppose I just want the fields SKU and store. So I'm going to say select SKU comma store from sales data all. We always end the query code with the semicolon, and it's going to give me all the data, but just for the fields SKU and store. Now you'll notice in the data that for each SKU for each day I have the quantity sold and I have the price that is sold at, but I don't have revenues, which is price times quantity. Well, I can easily ask in SQL language to multiply those quantity and prices together, and do it like this. We go into our SQL code, and in addition to SKU and store, we say sum, and then in the parentheses quantity sales times price, and again from sales data all, and then what that'll do, it'll multiply those two columns together if we do it right. And then I'm going to, in the SQL view, I'm going to run it. Now, let's stop here for a second. What this error means is that it can't just create a new column besides SKU and store that has price times quantity, but it will aggregate price times quantity for different variables, and so it's telling me SKU needs to be part of an aggregate function. That probably doesn't mean anything to you, but I think it will after I show you how I'll adjust the code. I'm going to go back to my original SQL code and tell it to group it by SKU and store. So I'm just going to add to the end of this, group by SKU, comma, store, and then I'm going to run it. And now it's telling me for every SKU and store combination, the total revenues. So for each possible SKU at each store, it's telling me the total revenues for that SKU in that store. Now I know you're not used to doing hard coding like this, so I want to point out a couple things. One, the way the Access interprets the code, it assumes that it's going to end at a semicolon. And so this means you can break the line of code into multiple lines, and it's just going to keep reading the code until it hits a semicolon, and that's when it executes the query. So you always want to make sure you're ending your code with a semicolon. Now notice it lists the SKUs and stores in no particular order, and suppose I want it to show me the SKUs and stores and their revenues in order from the highest revenues to the lowest revenues. So at the top, I want the SKU and store combination that gives me the largest revenues. And how do I do that? I'm just going to go back to my query. I'm going to start a new line, but it's going to be before the semicolon, so it's still the same command, and I want to order it by the sum of quantity sales times price, and I want it to do so in a descending order. And then I run it, and that's exactly what it's going to do. Now the revenues are displayed in order from highest SKU store revenues to the lowest. Now I want to pause for a moment here and talk about like where I learned this. I knew I wanted to use SQL because I needed to for web programming. I didn't go to college to learn it. I didn't learn it when I was in college. Most people, the more advanced coding that they're doing, they're going to learn themselves. They're going to be self-taught from the internet. Sometimes when I get stuck, I'll get some cheap $20 courses from udemy.com. And you're going to find this in your career. Much of the software you're going to use in your career, you're going to teach yourself. And part of what we're doing here is just giving you some exposure to SQL to give you the confidence that if you need to do SQL at work and more advanced things in SQL, you can do it. You can teach yourself. Now suppose I want to export this query into an Excel file. It's easy. I just right click on the query, go to export, choose Excel, and it's going to put it, choose the directory and the file name I want to go, and it will save it at that place. And then I can open up query 1 in Excel, and it's going to be there. So a lot of times at the workplace, the data you use in Excel, you will first have to retrieve from a database like we just did. Okay, now instead of just giving me every SKU and store combination, suppose I only want the SKU and store combinations that have the top 30 revenues. So just the top 30 numbers. To do that, I'm going to go back into my query design, and I'm going to still in the same line of code, so I'm doing it before the semicolon, limit 30. I'm going to try that, and it didn't work. And that's the code I'm used to doing. So what do I do now? Well, I'm going to ask the internet. So after Googling my question, how to limit the number of records in a query in Microsoft Access, I find out that this is the code I need to use. And when I run it, well, now it's going to work. Now it's going to, when I run it, give me the top 30 SKU store combinations in terms of revenues. Now remember, in the data we have for each SKU the quantity sold and the price for every single day in the Stillwater store. So that same SKU number is going to pop up like every day. Suppose I want a list of all the unique SKUs that are in the data. How do I do that? Well, when I actually did it, I just Googled how to do it, and I experimented with the code until I got it to work. And here's what I found was the workable code. Well, to do this, I'm going to go back to my code, and instead of select SKU, I'm going to say select distinct SKU from the table sales data. all. And then we're going to run it, and there we go. We're going to get our list of each unique SKU. And of course, I can export that to an Excel spreadsheet if I want. Now let's say in the data I want to know for how many years are there data in the data set. Well, to do that, there's no variable for a year, is there? So I can't say distinct SKU, distinct year like I did distinct SKU, but there is a date in there, and within SQL there are time functions which we can use. And when you do some Googling, what you find is that we can do this. We could say select distinct select year, sorry, and the field name is date. And so when you put year in parentheses date, it will interpret it that as the year. And then I want to know the distinct years for which data are available from sales data all, as usual, ending with a semicolon. And we run it, and let's see if it works. And sometimes I forget where things are, but yeah, it's in query design, so I'm going to hit run. And yeah, there we go. So I've got data from 2019 to 2023. Okay, I'm going to start going a little faster now. Suppose I want to select all data just from, let's say, one particular year. Let's say we want to select all the data in sales data, all. Select all the data in that table where the year is, let's say, 2019 or 2023. Let's say 2023. We run it, and there we go. We only get data for 2023. So if I just wanted to look at data for 2023, I run that query, and then I can export that to a spreadsheet if I need to. And we can refine things even further. Suppose now we only want data for 2023, and we only want data for this SKU, this particular SKU. We run that code, and we get that SKU just for 2023. Suppose now I want to know how large my table is in a data set. Like I want to know how many rows of data I have. I can't just go to the table and scroll down because these data sets might have millions and millions. And it's not made to like just screen to the end of a data set. So what we'll do here is we want to say count all. We want to count all from sales data all. And it tells me I have 2,739,000 observations, a good bit. And just to recap, important data used by companies that's shared by many people usually be stored on databases, not spreadsheets. These databases can have multiple tables, and some of those tables may have a million rows of data. And SQL, Structured Query Language, is the universal language that we interact with those databases. Whenever a website interacts with the database, like most websites do, SQL language is how they interact. And I've interviewed a number of students who, when they get in the real world, they find they have to deal with such large data sets. They can't use spreadsheets, they can't use Power BI because it can't handle that amount of data. And so they have to learn SQL code if they didn't learn it already. That's why I'm having you getting some exposure to it.